Hello, in this video we are working on graphing polynomials, and I am having some allergy issues, so I apologize in advance for any sniffling that you're going to probably hear. And anyway, so when we're graphing polynomials, we've got these steps here that you want to follow. You want to make sure that your polynomial is written in what we call root form. Okay, now root form is going to be where you have your leading coefficient in the front, and then you have x minus, and I'm going to say r sub 1 to the m, and r sub 1 meaning that that's your first root or any of the roots, okay, which are like zeros, okay, and m is your exponent, obviously, and then x minus r sub 2, and maybe that's a different exponent, that's a different root, and so on, where you have each of those roots represented and the different exponents and multiplicities represented as well. And then you plot your roots on your x-axis, and then you think about your multiplicities and how those roots are interacting with the graph, and then you also need to think about your end behavior. So let's go down here and just do a quick little review, because what we've covered in the past is a situation where we gave you the graph, okay, we gave you the graph and you had to find the equation. Okay, so like I said, as a quick review here, okay, we do not know our a value, right, when we start the problem, so you put an a in there, and then it's x minus your root, and you have a root at -3, so it actually becomes +3. You have a multiplicity of 1 there, and then you have x minus the -1, so it'll be x plus 1. You have a multiplicity of 3, and then it'll be x minus 2, and you have a multiplicity of 2. And then you solve for your a, so here's where we can use our y-intercept. We put the 12 in, and we put the 0 in, and we're going to solve for a. Okay, so I'm just going to finish those steps out here really quick. And a does equal 1, so there's an understood 1 right in there, right? And so this was our answer written in your complete function root form. All right, so like I said, that's all review. We've covered that in the past. And so you guys already know a lot about your polynomial graphs, because you had to understand what was going on with the graph to set up your equation and then do all of that algebra. Okay, so if we look at this example here, I wanted to talk with you about one of the challenges you're going to have when you sketch these graphs. So if you look at this function here, you can see we have 3 factors. All right, so we have an x-intercept at 3, and it has a multiplicity of 1. We have an x-intercept at -2, and it has a multiplicity of 2. And we have an x-intercept at -4, and it has a multiplicity of 1. So you know, just looking at this equation, we already know this information. Okay, and you can see I've got 2 graphs down here, and the x-intercepts are already marked on the graph. So one option, okay, and this is where, like in a classroom, what I would do is I would just say, hey, sketch what you think the graph is, and then there would be different versions of the graph within the classroom, and I would put some of the different versions up on the document camera, and we would say, hey, okay, these people have sketched different things. Let's talk about which one is the correct graph and why, how you know it's correct. So one of the graphs I would see in a class when I did that activity would be something like this, where a student has, let's see, something kind of like this on their paper. Okay, and then another version of the answer that I would see is something like this. Okay, and you can see that both of these students, okay, have the correct multiplicities. Okay, at -4 has a multiplicity of 1, and you can see both of these graphs have the correct behavior at -4. At -2, we have a multiplicity of 2, and so you can see you have the correct graphing behavior there at -2. And then at your x-intercept of 3, we have a multiplicity of 1. Okay, so similarly, so each of these students have, plotted the correct x-intercepts, and they have done the correct behavior at each of these multiplicities. But obviously the graphs are different, okay? So what it's going to come down to is understanding your end behavior. Now on a graph like this, you could find your y-intercept, okay? And see what that is, and that would help you figure out which graph is correct, and some students will do that. But there's going to be times when sometimes the y-intercept doesn't help you. A lot of times it does, but sometimes it only helps you for that little part of the graph, and there's still some uncertainty with the other part. So really what you're going to always want to rely on is your end behavior. Okay, so so let's go to this chart. Okay, now I pulled this out of your textbook. Okay, so if you want a better view of this, I encourage you to go to your e-text and maybe print out that page, because they have a lot of great information in the textbook about this. But this chart is kind of nice because it organizes it in a condensed form. And if you have an even degree, you have this first column here, okay, and if you have your odd degree, you want to look at the second column. If your leading coefficient, which is your a value, is positive, okay, we're going to look at this row here, okay, because both of these are positive, okay, and if your leading coefficient is negative, all right, we are looking at this second row. Okay, so let's go back up to what we were dealing with in this previous problem. Now for the degree, okay, you add up your exponents. Okay, this is written in root form, so you add up your exponents. So we had an exponent of 1 here and an exponent of 1 here. So for degree, I want to think 1 plus 2 plus 1, which gives me a 4. Okay, so it's fourth degree polynomial. All right, so go back to our chart. Sorry for the scrolling back and forth here. And we need to think about this first column, okay, because we have an even degree. 4 is an even number. All right, and then our a value is 1, right? Remember we found the a value, and also, oh, sorry, that was the previous problem. Sorry. So yeah, sorry, I got myself off track there. So our a value is 1 on this one as well, but that was from the previous problem, not particularly this one. They do have the same a value, however. Now your a is 1, and that is positive. Okay, so we have an even degree and we have a positive leading coefficient. All right, so we need to use this information. Okay. Because that's the spot in the chart that matches each of our conditions. So our end behavior is, you can see both ends on the left and the right are going to be going up, okay? And the formal notation is down here on the bottom. Okay, as you can see, that's the more formal, but I like to think of it as up, up. I know that's not very technical in the wording, but I like to think about the left side is going up and the right side is going up. Okay, so that means this right here, okay, is the correct version of the graph, because each of these ends are going up. Okay, on the left side I'm going up, and on the right side I'm going up. Whereas this guy over here is not correct because the end behavior is down, right? It's going down on the left and it's going down on the right. Okay, so like I said, both graphs met the conditions of the x-intercepts and the multiplicities, but there's only going to be one graph that meets the conditions of your end behavior. All right, so Let's look at a couple more examples here. So we've got this polynomial given to us here, okay, and let's think about our x-intercept. So our x-intercept, I'll have an x-intercept of 1, and that has a multiplicity of 3, and I have an x-intercept of -1, and that has a multiplicity of 2. And my a value is -2, and we don't really need to worry about the 2. Really what we're worried about is the fact that it's negative, okay? And my degree, okay, remember, add up those exponents. My degree is going to be 3 plus 2, which is 5, okay? And that's an odd number. Okay, so I want to go to my chart and I want to think about having a negative a value and an odd degree. So that's the second column of the chart, and it's going to be this bottom section of the chart where the a value is negative. Okay, so we want to think about this information down here, and you can see on the left side it's going up and on the right side it's going down. All right, so I like to think of this as up down. Okay, and so I want the left side of my graph to go up and I want the right side of my graph to go down. So you kind of graph these a little backwards actually. So if we'll put our x-intercepts in here, so we got a -1 and a +1. And I want to think about the left side and the right side, okay? Now at my x-intercept of -1, I have a multiplicity of 2. All right, and so we know how that looks, okay, based on our previous knowledge. So I need for this left side to finish up, okay, and I also need that multiplicity of 2 to happen here. So I'm going to have to do something like that, okay. And then on the right side, okay, I have this x-intercept of 1, and I have a multiplicity of 3, and I need this to finish down. Okay, so you want that kind of that wiggle thing to happen there, like happens with your multiplicity of 3, where it kind of flattens out a little bit. Okay, and then just sketch. Sorry, this pen is very, let me fix that a little bit. It's very slippery. It's a lot easier to just graph with a regular pencil. All right, let me try to fix this. Now, you guys don't need to worry about how far you go up. I mean, you could find your y-intercept if you wanted to. And some students do that just because they really like to, they're just kind of curious of what it is. But we actually, at this point, we're just getting a sketch, okay? And you'll see that's why a lot of times in the directions it's just going to say a sketch, because this guy may shoot way up high or maybe lower. It just kind of depends on some other parts of the polynomial. But like I said, just make sure you are showing the correct end behavior on the left and the right, and you're showing the correct behavior at these multiplicities, okay? And this really needs to kind of flatten out there. Okay, I hope your graph looks better than mine because you're just probably using a regular pencil instead of this weird stylus thing that I have to use. So this would be a perfectly good sketch, okay? So let's look at the next one here. Now the first thing is you want to get it in root form or factored form, okay? So you have to bring in your factoring here. And so this one does factor to x minus 7, x plus 2. All right, and you're going to have an x-intercept at 7, and it has a multiplicity of 1, and you're going to have an x-intercept -2, and has a multiplicity of 1. We know this is quadratic, right, because we've already done a lot with quadratics, and quadratics are just a special type of polynomial, by the way, when you have a degree of 2. And let me go and write that down. We have a degree of 2. Now let me point something out here real quick. When your polynomial is in standard form, okay, like it was up here, your highest exponent is your degree. Okay, you do not add up any exponents, you just look at your highest exponent, so you can see the 2 there. And when your polynomial is in factored form, that's when you're going to add up those exponents. Okay, so this one, the exponents were 1 and 1, so 1 plus 1 is 2. Okay, so just be careful that you understand the different ways to get a degree based on whether it's in your standard form or whether it's in the root or factored form. All right, and then you guys know a lot about quadratics now, so we also can look up here and we know that we're going to have a y-intercept of -14. You could find the vertex even if you wanted to, right? You guys know so much now about how to do quadratics that this is super easy because you almost have more skills than you actually need. So let's go ahead and plot our x-intercepts, -2 and 7. Okay, and like I said, it's going to have a y-intercept of -14, so it's actually going to run off the graph a little bit. And our degree is 2, all right, and our a value is 1, so our a value is positive and our degree is even. Okay, so going back to the chart here, a value is positive and degree is even, so we're back into this first one that we used earlier. And so you want that up behavior, and you just want your graph to, you know, show that multiplicity of 1 through there. I'm actually going to let it kind of run off the screen a little bit there because of the y-intercept. I can't, if I was you, I would sketch. Let's see if I can move my, there we go. Maybe I can adjust this. It would go down, right? It'd go down to -14, so it kind of run off the grid there. And then it would come back up. Oh, goodness. Something like that. Make sure it has that nice U shape to it. Okay, let me get some of this out, clean it up just a little bit. There we go. And has that nice parabola look to it. Okay. These take a little practice, right? The more intercepts you have with the different multiplicities, sometimes that can get a little tricky to figure it out. But like I said, it's kind of like a puzzle. Just put all your little pieces together and think about all the little puzzle pieces, and then eventually you will get to the graph that's correct. I'll see you online.